first? Can you all see my screen? Right, good. So last week we basically talked about testing principles, right? We discussed 7 testing principles. Then we talked about the testing process, 5 phases of testing process. And then we talked about software quality assurance architecture. There were 6 components in that SQA architecture, and we discussed how we can build the total architecture based on those components. Today we are going to discuss test design techniques, right? So in this lesson, you will be learning what is a test design technique, then the advantages of test design techniques, categories of test design techniques like black box testing, white box, and the experience-based testing. Sometimes you may have learned these things in your software engineering lessons or in any other subject, but in this course, we are going to talk about these things in detail. Then we'll do a comparison between these techniques. Then we'll discuss how to choose the test design technique, which one is the ideal technique. And finally, we'll discuss how to write a test case document. Okay, right. First of all, we'll see what is a test design technique. Basically, it is a procedure of selecting or designing tests, right? Simply, it is a procedure of selecting or designing tests during the testing phase, right? Or else we can define this one as a process of determining test conditions, test cases, and test data during software testing. Here, it should be in the same line. We determine test conditions, test cases, as well as test data during the testing phase, right? Last week I told you what is the test condition. Can anyone remember? What is a test condition? Basically, it is a component which consists of number of test cases, or else we can define it as a constraint, right? A constraint that we should follow when we test an application, right? Okay. Then, a test design technique is based on the structural or the functional model of a software, right? You will understand what is the structural and the functional model later on. Then this is very helpful at finding faults, the test design techniques. And following a test design technique is the best practice in software testing. And also it is a way of deriving good test cases. Okay, right. These are very simple things. Then, what are the advantages of having a test design technique? First thing is it helps to find faults, and it helps to find the faults early in the software development life cycle. You know, the faults found early are very cheaper to fix than the faults found in later stages of the software development life cycle, right? And also we can find the significant faults early in the SDLC, right? And also we can prevent those faults from entering into the system, and also we can prevent fault multiplication. Then it says no additional effort is required, just need a rescheduling of the test design, and also change request can be reduced considerably through test design. If we have selected a particular test design technique, then the change requests can be reduced considerably during the test design, and also no additional effort is required. We have to just reschedule the test design if we have a particular test design technique during the testing phase. Okay, right. Then when it comes to categories of test design techniques, First one is black box design technique, white box, and the experience-based testing techniques. When it comes to black box, we call this one as a specification-based technique. Why is that? The reason is here, if this is the source code of the program, this is not visible to the tester, right? Only the specification is given, the source code is not visible, and then the tester tests only the inputs and the outputs of this source code, right? They can't they can't test the source code, they just test the input and output to the source code by looking at the specification, right? That's why we call this one as a specification-based technique. Then black box test design technique එකේදී source code එක visible නැහැ. ඒ නිසා තමයි අපි මේක black box කියලා හඳුන්වන්නේ. source code එක black box එකක්. ඒක test එකට visible නැහැ. ඒතර මෙතෙන්දී අපි කරන්නේ source code එකට දෙන input එක සහ output එක අපි test කරනවා අපේ specification එකත් එක්ක align වෙනවද conform වෙනවද කියලා. ඒතර ඒ නිසා තමයි මේක specification based එහෙම නැත්නම් black box design technique කියලා අපි identify කරගන්නේ, right? Then when it comes to structure based, here the source code is completely visible for the tester, right? This is visible. Then the tester can directly go through the structure of the code, right? He or she can read the code and analyze the code and do the testing. That's why we call this one as a structure based or the white box design technique. Then the experience-based testing is totally based on the experience of the experts, right? We'll discuss these things one by one later on. At the moment, did you understand the difference between the black box and white box testing clearly? Did you get it clearly? Okay, good. Then we'll talk about the black box testing, right? Here, as I mentioned earlier, the testers interact with the user interface of the system by providing inputs and examining those outputs without knowing the source code, right? Without knowing how those inputs are worked within the system. It completely ignores the internal mechanism of a system because the source code is not available. It is not visible for the tester, right? And also by giving inputs and then checking outputs, they verify whether the observed behavior conformed with the specification or the requirements of the final user, right? So here it says it verifies the correct handling of the external functions provided by the software or whether the observed behavior conforms to user expectations or product specifications. This is very important. It ignores the internal mechanism and focuses solely on the outputs generated in response to selected inputs and execution conditions. In the case that the outputs are found to be correct, black box testing disregards the internal path of calculations and processing, right? So if the output is correct according to the given input, and if it is conformed with the user specification, right, we are not going to look at the internal part, things within that code. Right? We disregard the internal parts and the internal things. We don't care whatever the things happen in the source code. We just look at the input and the output only, right? Typically, while performing the black box test, a tester will interact with the system's user interface by providing inputs and examining the outputs without knowing how and where the inputs are worked upon. The tester doesn't know how these things, let's say a calculation, how these calculations are done during the system, how these things happen within the system, right? He doesn't care these things. He just input some values to the system and examine the output of that system and check whether the observed behavior or the observed output is conformed with the user specifications. Okay, clear? මෙතෙන්දි පුතේ අපි source code එකේ මොනවද වෙන්නේ? අපි example එකක් විදිහට calculation එකක් ගත්තොත් ඒ calculation එක system ඇතුලේ code එකේදී මොන විදිහටද සිද්ධ වෙන්නේ කියන දේ consider කරන්නේ නැහැ. එතකොට මෙතෙන්දී අපි කරන්නේ අපි input එකක් විදිහට values ටිකක් දෙනවා. අපිට හරි calculation එක එනවා නම් output එක විදිහට ඒක user අවශ්‍ය ඒ calculation එක නම් අපි බලනවා specification එකත් එක්ක. එහෙම නැත්නම් user requirements එක්ක අපි compare කරලා බලනවා user අවශ්‍ය මේ output එකද කියලා. ඒතර දීපු input එකට සහ user ගේ specification එකට අනුව observe behavior එක එහෙම නැත්නම් output එක correct නම් එතනින් එහාට worry වෙන්නේ නැහැ අපි internal mechanism එක ගැන. නෝක තමයි කෙටියෙන්ම black box test design technique එකේදී වෙන්නේ. තේරුණාද? Please ask if you need more clarifications. Right. Then, under black box test design technique, right, there are 4 techniques which we can use. Or else we can divide this one into 4 categories: the equivalence partitioning, boundary value analysis, decision tables, and the state transition diagrams. Right? Then, depend on the specification, we can determine whether we are going to use all the techniques or few of these techniques. Okay, here it says, depending on the specifications, the coverage can be determined so that all the scenarios are covered with the above mentioned techniques. Use cases and test data supporting the use cases can be taken as the input for these test design techniques. We can use cases and also test data of those use cases as the inputs for these test design techniques. Right? And based on the specification, based on the number of scenarios we have, we can determine the coverage. So we can use one or all of these techniques according to the specification. Okay, right. First, we will discuss the equivalence partitioning technique. Listen carefully, these techniques are very important during the testing phase. Okay, right. Here, basically, we divide the test input data into a range of values, right? And then we select one input value from each range and we test that value, right? So using this, we can increase the efficiency of testing. We can improve the coverage of the testing. Okay, right. Actually, this is not a new thing. When we are writing test cases, normally we do this. If you can remember how to write a test case, right? This is actually a thing which we normally do when we write a test case. Okay, we'll discuss an example. Before that, here it says, this is a black box method aimed at increasing the efficiency of testing and at the same time improve the coverage of potential error conditions. Here it says the test input data is partitioned into groups, or we can divide the test data into a range of values that are expected to function same way, right? An equivalence class is a set of input variable values that produce the same output results or that are processed identically. There's something wrong with these lines. Right. Here, okay, it says test data is partitioned into groups that are expected to function same way, which means the data belongs to each category. The data belongs to one particular category or a partition are expected to function in a similar manner, right? Or they produce the same output results. Okay, I'll tell you an example, then you can understand this one properly, right? Now assume, right, here, look at this example. Assume we have an input field to enter the age of a person, right? Let's say this is a registration form and there's a field to enter the age of that particular, maybe a student or a customer or any person or an employee, right? And then this input field accepts values between 18 to 56, right? That is the condition. It accepts values only from 18 to 56, right? Then when we do the equivalence partitioning to this input field, we have to identify the valid inputs as well as invalid inputs. So obviously the valid class or the valid input is between 18 to 56, right? You can understand that one very easily. This range is valid between 18 to 56. Then there are two invalid ranges, two invalid partitions, right? This is assume 18 to 56, right? If this is 18, if this is 56, right. Here you can see this range is invalid and also this range is invalid, right? So we can name this range as less than or equal to 17, or else you can say just less than 18, it is correct. But this is more understandable, right? Less than or equal to 70. Then this range is greater than or equal to 57. Again, it is invalid, right? Likewise, we can partition the input data of this age field into three partitions or into three classes, like the valid class and two invalid classes, right? Here it says valid input is 18 to 56. Then invalid inputs are less than or equal to 17 and greater than or equal to 57, right? Based on that, we can identify the valid class and the invalid classes. So valid class is the values between 18 to 56. Invalid class 1 is less than or equal to 17. Then here, another invalid class should be there, invalid class 2. There's another invalid class here. Invalid class 2 greater than or equal to 57, right? Did you understand this one? Here, as I mentioned earlier, the values within a particular partition or a range gives us the same output or the same result, right? අපි දැන් කලින් slide එකේදී කිව්වා. Sorry. Here we talk that input data is partitioned into groups that are expected to function same way, or here it says an equivalent class is a set of input variable values that are produce the same output results or that are processed identically. Think about a one class, one equivalent class, right? Here within a class, all the outputs are same, right? Or all the values are behave in the same manner. For example, if this value is 18 or if this is 56 or if this is any value between 18 to 56, the output will be the same output. Did you get the point? දැන් මෙතන 18ත් 57ත් අතර නම් valid class එක තුල system එක behave වෙන්නේ එකම විදිහට. So ඊළඟට invalid class එකක් ගත්තොත් ඒත් එම අපිට හැම වෙලාවෙම output එක එන්නේ මේක invalid කියන එක. එහෙම නැත්නම් error message එකක්. ඒක තමයි අපි කියන්නේ මේ equivalence partition එකක් ඇතුලේ අපිට හැම වෙලාවෙම same output එක එහෙම නැත්නම් මේ data එකම manner එකක behave වෙනවා කියලා. equivalence class එකක් හැම වෙලාවෙම same output එක තමයි produce කරන්නේ. තේරුණාද? Okay. We'll get another example, right? Now I need the answers from you. Right. Now assume there's an input field to insert, let's say, quantity. Yeah, I'll draw it. Quantity. Where's the pen? Right. Here, we have an input field to insert the quantity values, and it accepts values only from 1 to 100. Right? We can insert minimum 1 as well as maximum 100 as the input of this quantity field. Now tell me, what are the valid and invalid inputs we can identify in this case, in this example? Okay, tell me what should be the valid input. Yes? What is the valid input here? Yes, 1 to 100 is the valid input, right? I'll write it here. 1 to 100 is the valid input. Then what is the invalid class 1? This is the valid class, right? Then what is the invalid class 1? Here, what is the first invalid class? Yes. It should be less than 1, or else you can say that less than or equal to 0, right? Not less than or equal to 1 because 1 belongs here. Okay? Right. Then what is the next invalid range? Here? Yes, greater than 100 simply, or else you can say that greater than or equal to 101, right? Did you get it clearly? Then what we normally do is we write test cases for each and every equivalent classes once we did the equivalence partitioning, right? Then we can test all the possible inputs, right? Like valid and all the invalid inputs to a particular field if we write test cases for all these partitions. Don't you know what is the test case? I think you have written test cases in your software engineering lessons. Is that so? Can't you remember the test cases? Right. I will show you what is the test case is. Can you remember something like this? In a test case, first we assign a test ID, then we write the description of that particular test case, and we write what is the expected result, and then we execute that test case, and we write what is the actual result, and then we compare the actual result with the expected result, and we write the status of that particular test case. Have you ever used this kind of a format to write test cases? Because in the very first day, you told me that you have written test cases before. Yes or no? Okay, good. Right. So basically, we use test cases to compare the expected result and the actual output of a particular input field of a system. Okay, right. Now, did you clearly understand what is equivalence partitioning and how to do that? Shall we move to the next technique? Okay. The next technique is boundary value analysis. Right here, I'll move to the previous slide again. The concept behind the boundary value analysis is, here we normally assume that most of the times errors can be observed in the extreme ends of these input values, right? Which means the lower and upper limits of these partitions. Okay, so if we are checking for these boundary values, also known as range checking, right? The equivalence partitioning and the boundary value analysis is linked each other. So we can use these two techniques together at all the levels of testing. දැන් මෙතෙන්දී අපි කරන්න පුතේ මෙතෙන්දී අපි assume කරනවා boundary value analysis කියලා කියන්නේ මෙන්න මේ partitions වල boundary values වල ලොකු possibility එකක් තියෙනවා high possibility එකක් තියෙනවා කියලා errors තියෙන්න. ඒතර boundary value analysis එකේ අපි මෙන්න මේ edges එහෙම නැත්නම් මේ partitions වල extreme ends අපි check කරනවා මේ වගේ errors තියෙනවද කියලා බලන්න, right? It is observed that in most applications, errors occur at the boundary values. Boundary value analysis can be considered as the next part of equivalence partitioning. As I mentioned you earlier, these two can be combined together, right? Where test cases are selected at the borders of the equivalent classes. In boundary value analysis, we select test cases which are in the borders or the edges of the previously identified equivalence classes, right? And here it is must to test both the sides of each boundary. And we assume the system behaves differently on either side of a boundary. For example, it's like this, right? Previous example, we had 18 and 56 in the as the partition. Okay, here when we do the boundary value analysis, we have to look at the edges of these equivalent classes, right? Edges means basically the 18 and the 56, and we have to test both the sides of each boundary, which means this side as well as this side. Here also we have to look at this side as well as this side. Here the assumption is system behaves differently on either side of a boundary. For example, when we look at this boundary, here in this side, if we select a value in this side, system should behave differently If we select a value from this side, the output should be different. It is correct, right? Because if we select a value less than 18, system generates an invalid output or an error message. But if we select a value greater than 18, it should be less than 56, then the system generates a correct output. That's why here it says system behaves differently on either side of a boundary. අපි identify කරගන්න boundary එකේ දෙපැත්තම අපි check කරනවා සහ ඒ දෙපැත්තේදී system එකේ behavior එක වෙනස් වෙනවා කියලා අපි මෙතෙන්දී assume කරනවා. ඒ assumption එක මත තමයි අපි මේ දෙපැත්තම මේ විදිහට test කරන්නේ. මොකද දැන් මෙතන ගත්තොත් 18ට වඩා අඩු වෙනම් system එක generate කරන්න error message එකක් 18ට වඩා වැඩි නම් correct output එක අපිට දෙනවා. Right? So here basically in the boundary value analysis, we have to look at four main scenarios. The minimum, right, which means in this case, minimum is 18. Then just below the boundary values, which means just below the minimum, that is, let's say 17. Then the maximum, it is 56. Just above the maximum, that is 57. And also we have to look at, there are two more actually, just above the minimum, that is 19, and just below the maximum, 55. Right? Likewise, we have to look at both the sides of each boundary. This is important. Did you get it clearly? Always remember, we have to look at both the sides of the boundaries. Okay? Now we'll discuss another example. Right. This is regarding an automatic grade assignment field, let's say in a result detail page. Right? When a teacher enters a grade, it is a numeric value, a letter grade should be automatically assigned. It's something like this, right? The grade field is there like this. And teacher can assign a numeric value to this box, to this field, right? Once a teacher enters a numeric value, the system will generate a letter grade as a result, right? Let's say if teacher enters 85 as the numeric grade, system generates this one, letter A, as the grade belongs to that particular student, right? If teacher enters, let's say 30, system generates F as the result, right? This is the requirement of this grade assignment in the result detail page. Here the rule is the numeric value of the grade can be 0 to 100. If the student scores more than or equal to 80 marks, letter grade should be A. If it is less than 80 and greater than or equal to 60, B will be the grade. If the score is less than 60, the letter should be F. Actually, this is not very practical, right? Normally, we don't fail students if the marks are less than 60. So don't worry about that. This is just an example. All බය වෙන්න එපා 60ට අඩුයි නම් fail කිව්වහම normally practical scenario එකේ එහෙම වෙන්නේ නැහැ. මේක just an example එකක්. ඔයගොල්ලන්ට මේ boundary value analysis එක identify කරගන්න ලේසි වෙන තමයි මෙහෙම දාලා තියෙන්නේ. Right? Then the assumption is the numeric grade field accepts only whole numbers. We can't give decimal or the fractions into this grade field. It accepts only whole numbers. Right? මේක පූර්ණ සංඛ්‍යාව විතරයි අපිට මෙතෙන්ට දෙන්න පුළුවන් කියලා assumption එකක් දීලා තියෙනවා. Okay. Now what I need is do a boundary value analysis for this grade field, and you can send me the answers. Right? If you need, you can draw You can write the answers on a paper and send me a picture, or else you can use a Word document and you can share the screen with me. And is it possible to put the answer on the chat box? Yes, it is possible. But here it is very easy if you can draw a line like this and then mark the values on this line, then you can easily identify the boundary values. Okay, right, do it quickly. I'll give you 5 minutes.